Good morning. Hello, happy Sunday. Hope you're all doing good today. Ready for the week tomorrow. I'm not, but I'm glad I still have the rest of today, and then I'll hopefully be ready for tomorrow. Nope, still too hot. All right, let's jump into what we're doing today, which is playing with Rapier2d. So, where we left off on Friday was this. We were able to create essentially an entity, give it have it be affected by gravity, have it bounce, and something underneath it where it then jumps on it. Now, I don't actually know what that something underneath it really looks like because I don't think I actually did. I can't remember exactly what I did to create it. I made it a platform. So see what we did here. We have our platform, which is a rigid body. We gave it a position, which is, exactly the same X position, but, higher Y, so it's farther down. And then how's that collider? Don't think I gave it. Okay, so static collider. Oh, it's a radius of 10. So it is like the same size as the other thing. So it is a circle. If I make this like 1.0, so like a very small radius. And we try running you again. Now it's going to look the same because I'm not really being... All right, it's still able to fall on it. So even 1 pixel, I guess like 2 pixels really, it's essentially like the nail. So which is perfect. That's kind of what we're going for there. Now, what I want to do today is just see how many entities we can get on the screen at the same time before we start having performance problems. So I want some kind of container, and I want to drop a whole bunch into the container, and they're all going to bounce and interact with each other. That's kind of what I want to end up doing. And see if I can take this camera and route it around a bunch of different things. Point it. See if this works. Cat cam. There we go. Kitty cat is visiting us today. Well, at least a little bit this morning. We'll see how long he ends up staying. So if I want to like create a whole bunch of these, it's not too terribly hard. We're gonna have a rigid body that we create. So I want to have a function that creates these. That should be simple enough. We should be able to do a private function like create ball. I don't know if we need to... Are there any unwraps here? I'm not seeing any unwraps in any of this. Even build doesn't return a result. So I don't think we need to return a result at all. All right. So you're not going to return anything. And then what we want to do is the first thing, okay, so the rigid body. Okay, so we're going to create a rigid body, which is going to be the ball itself. So I guess like the ball body. In this case, we could probably call it body because we're in a context of create ball. And we're going to use the rigid body builder new. Body status dynamic. So we learned that there's 3 of these that we can use. Dynamic means that it's going to be affected by gravity. Then there's static, which means it's sort of like a platform. It's not going to be affected by gravity. And then there's just like none, where it's just not going to be affected by anything whatsoever. Dota2 Attitude, hello. How are you doing this fine Sunday? So what is this? This is body status. Oh, kinematic and static. Never mind. Okay, kinematic is where it's like on some kind of platform and it's moving like that or that. We're looking for a dynamic here because we want this to be affected by gravity. Okay, so then after that, we can run all these different methods that will basically give it like whatever it is. So I kind of want to go to rigid bodybuilder. There's my browser. I want to head over to Rapier2d. Oh, you hit your 160 hours for 4 weeks? All right. Congratulations. Well, I guess like, all right, the next steps, right? So what's next for you? Like, what do you need next? Or is that everything? Let's see. Should do that Friday as you worked 11 hours on Saturday. That's a long work day. That is a long work day. I hope you get some time off. 11. I used to be able to do those pretty easily, and now they destroy me. Yeah, you plugged away. All right, let's see what we were doing. Oh, right, we were looking for rigid bodybuilder. Got up at 7:30, it helped a lot. Yeah, getting up early, I found like if I want to work more, like get more done throughout the day, getting up early as opposed to staying up late, that's how it works for me. I do know some people that do the opposite. Whatever works for anybody, right? Okay, so now we can start seeing what we need here. It actually looks like new and like new static, like either of these would work. I could just do rigid bodybuilder, new dynamic. It still is going to return self. So it doesn't really matter. But these ones, okay, so sets the scale applied to the gravity force. Oh, so this is the scale applied to the gravity force. Now I think if we come here, our gravity is set to like this because we just made it. Epic Blarg, hello. You worked 300 to 320 hours, 3 months last year. Not super healthy. No, unfortunately it is not. If there's something that I could do is like get rid of that. Like I personally, it's my belief that like we don't actually get a lot more done with those extra hours. It's diminishing returns, definitely. I don't think it's worth the the damage it does to our bodies and brains. All right, well, Zilby left the window, so I turned off the cat cam. Okay, so I don't think I need like a gravity scale to be higher. Dominance group, interesting. Okay, I don't have a group. Translation. Okay, so I don't have a translation or a rotation for this. There's circles or balls, so rotation doesn't even matter. Okay, position. Sets the initial position. translation and orientation of the rigid body to be created. So position is something we care about, and that's going to be an isometry. What underlying graphics engine is used when you're playing around with Rapier? I do not think that it has its own graphics engine. So right now I'm using it with GG Easy. So what I'm doing is in my draw loop, I'm looping through basically all of the bodies that we have, and then generating a single mesh and then building that and displaying it. So that's what I'm doing right now. I haven't figured out how to like get all the the size information out of it, but hopefully it shouldn't be too terribly hard. But okay, so if I want to create this, so we're going to add a position. You need to be in isometry. Isometry and isometry 2, I would assume. I can do a new. Utsby, hello. We used to have an identifiable group of pizza overtimers who would just stay in the office to get the free dinner, but blatantly do no work. Yeah, I think the thing that pisses me off the most with overwork is when the managers go home and leave everyone else who's there working there. That's like the biggest no-no that you could possibly have. Like, if there's an emergency and one person has to stay, manager should be there too. Even if the manager is literally doing nothing, they should be there. Like, just to provide emotional support. Like, literally nothing else. That's still fine. Okay, so then in here we give it a vector 2 and then the angle. So we know the angle is going to be 0. So here is going to be our vector 2. So we want our vector 2, new. Oh, I love that we're doing that. Pizza it's funny what some people will do for like free food or free pizza. And it doesn't even have to be that good of pizza. They'll just like stay after hours. You know, it really helps if you have no family and like no hobbies and no other like outside of work, requirements, then yeah, you're gonna spend a lot more time in work. Just tell your manager to leave me alone. Oh no, okay. Caveat there. The manager shouldn't be like sitting there going like the entire time. No. That's not helpful either. The manager should be like present, but not like in the way. What I mean by that is like if you're in the building, like if you're physically in a building together, the manager can go be in their office there. If it's like an online thing, the manager can be just basically every once in a while, like I don't know, like I usually for overtime like have us all be on a Teams or a Zoom call or whatever, and then as a manager, if I'm not doing it, which these days usually I am because I'm a senior developer also, but if I'm not, I would just mute and like turn off my camera and just try to like make it appear like I'm not there, but like still be there in case I'm needed. Someone worked all night from 9 a.m. to 2 p.m. to finish something. At 2 p.m. goes to management, asks if he can go home. Manager says no, we work 9 to 5. Yeah. That kind of thing is what upsets me so much. Oh man, okay, so I watch a lot of Simon Sinek and some other like people to people on the YouTubes that I and like read all the management book, trying to improve my own management skills. That company lost 74% of the staff in 2 months. Yeah, that could happen. So there's a video that came up very recently from Simon Sinek, which I like really love. And for any of those type of leaders, I'm trying to find it. History. Oh, I can just go to Simon Sinek's channel. It's like the most recent one. Where are you? You are. Here it is. I'm not gonna. Nope. Not gonna play it, but I love this. Rules are for lazy leaders. It's a little bit of clickbait there, but what he means is blindly enforcing rules is definitely a lazy leadership thing. Oh, that was a young manager. I mean, even young managers who actually want to be good managers can still learn to be good. It's just, one of my mentors likes to say, management is hard, ergo, most managers are terrible. I agree with it. All right, where are we gonna put this? Let's put this in just sort of like a random location. I don't know where I want. Let's actually do a random location. So I can set up RNG. Create a thread. Oh, if I want RNG, I need to bring in rant. It's not like you can get random numbers without a crate. I remember the young manager saying he's doing well, and I burst out laughing. Nowadays they hate. Yes, I was talking to my my CTO, who's also my like direct manager, the other day, and I was saying that people like me are hated. Like companies either hate me or love me, because when I come in, I make social change. I make social change. And if you don't like that, then it's really dangerous for the company, because it means that I'm going to be like saying things, like doing things that like are better for like actual work. Epic Blarg, hello. Your manager is a jerk. Also, you're self-employed. Looks disappointingly into the mirror. I guess like some like serious talk from that. Like, I know it's a joke, but something that I learned is, how can you expect to manage others if you can't manage yourself? It's like a really powerful statement. Is if you can like actually do the things that you're preaching, then that will make you a better manager. If you're only asking people to do stuff that you yourself can't do, and I don't mean like the actual work itself, I mean like staying late, things like that, like how much work you get done in a day, how the quality of work you're doing. If you can't like do that, if you can't hold yourself to a standard, then why can you expect to hold somebody else to a standard? But I have strong opinions about these type of things. Okay, so we want position. So I'm actually gonna do let position equals, just gonna do the vector new, vector 2, new. So let's make this, can also pass in a context. We'll do let height, drawable size, get that context. Okay, so we're gonna get this position. So let's do, our X is gonna be self.rng, gonna gen range between 0.0, and width. But for the height, let's just do like -10. So if I do that, okay, I was like really confused about the error message. I just didn't save. That's all. Okay, so back to you. So now I'm just gonna give you this position. And then, okay, so we have a position now. I don't know if I need anything else specifically in here. If we take a look at what we have. User data, an arbitrary user-defined 128-bit integer associated to the rigid bodies built by this builder. Is that for retrieving? I wonder if that's how I would potentially associate this specific like entity with something that I would also throw into my ECS library. Additional mass properties, so I don't know any more. That's probably like where I can do like an offset. Make you heavier. Print, oh, okay. I can have an additional principal angular, so I can have it starting off in like a certain velocity, I suppose. Right, these are all 0. Sets whether or not the rigid body can be created can sleep if it reaches a dynamic equilibrium. So if it stops moving, can it stop checking it? Which would probably increase the what is it? This could probably increase our abilities? No. Performance by a huge amount. Especially like when we're starting to get thousands of these on the screen at the same time. Enabled continuous collision detection. I don't think I need that. And then we'll build it. Okay. Okay, so that gives us a body. So that's essentially this thing gone. Okay, so then we're gonna insert the body and get a handle back. So then that body handle equals self.bodies insert body. Okay, that gives us this rigid body handle. We're then gonna take that. So we did that here. Now we create a collider for that rigid body that we just created. Which is, okay, so we're gonna do a collider builder. Shape. So this is a ball shape. Let's go. Okay, so we're going to be doing a ball shape, but we could also just do this ball. And pass in the radius at this point. So something that's really interesting is that the position is all 0 based, like the center of the object. And then this is all going to be about like the display of it, like what it looks like and how it, like the physics of it. It's like then combined with the physics of it, right? Because the other one has like the location, this one has the size, and the shape, I guess, is like for collisions. But also I'm going to use this for displaying. So we have the ball and radius. So what we can do down here is instead of that, we'll do ball and radius. Let's actually store that away in here. So we'll just actually, you know what? I don't know if I want to do that because I want to keep myself open to random sizes. So I'm just going to set this up here. Let's just do 10.0 for right now, and we can change that later. So we have radius. Now, once we've done that, look how many interesting shapes we can do. We're going to want to come down as we start seeing self. We can do a polyline. This might be important for us too. Okay, this is the first time we're seeing self in here. So I'm assuming that we're in order from top to bottom with like actual methods. Okay, so the user data, they also have this. We can associate them together easily in our own systems. Collision groups. Two colliders will interact if their collision groups are compatible. Okay, so this is what we did before. This is basically the layer system. So that's really cool. Solver groups. Forces between two colliders in contact will be computed if they're solver groups. Oh, so there's like multiple ways you can do this. So sensors, I don't really understand when I would use a sensor or like what that really is yet. Friction, I don't think I need a friction yet. Restitution. So this is what the bounce thing is. It says the restitution coefficient of the collider this builder will build. Okay, so let's give it a restitution. So if we look up here, we gave that restitution a 1.0, which is enough for it to like, it doesn't bounce more. It will still stop bouncing. Select the rule to be used to combine two restitution coefficients in a contact. So if two balls have restitutions, very interesting. So we might want to play around with this sometime in the future, especially when we're having like balls hit each other. Density, I don't know what I want to set for that. Mass properties, translation, okay. So we can set rotation here and in the other object. That's interesting. And then build. Okay. There's some things we can definitely play around with. Okay, so we have this. That means, okay, so we create our, so I created a density of 0.5. I don't actually know if I need that, but we can play around with it later if we want. So we create our collider. Now this is like creating the platform. I'm not gonna worry about that right this second. I'm probably gonna, we'll deal with that later. So I'm just gonna go ahead and remove you also. I just want something that falls from the top down to the bottom. Static collider. I missed something. Oh, okay, so we created the collider. And then, okay, that's then used here with static. So then, oh, static collider handle. Okay, so then we colliders insert. Have to give it the body handle. Okay. Okay. Got it. So then we're gonna insert those all into each other. Sensors usually means something that is collidable but has no physics response. Used in games for things like triggers for opening doors and such. Oh, okay. That makes a lot of sense. I'm guessing that Rapier has like a similar idea of how you're going to use it, because sensors will have a default density of 0, but you can still assign it to if you really need to, but they don't assume you want that. So is this the reason why in a lot of games for like speed runs, because like I noticed they were like, oh, we just like jump out of here and then we're not going to trigger the cutscene. They're using a sensor in that area, right? Like just have like a sensor entity that like does a collision detection. If you collide with this, trigger cutscene. Is that how it works? And then also like opening doors. Yeah, you'll have to trigger box or whatever. Okay, that's pretty cool. All right, so then in here, we take our collider. The speedrunners do shortcuts to avoid cutscenes as well as other triggers. It's really interesting because that means, yeah, so they're finding all sorts of triggers, either like the ones they want to trigger or the ones that they want to avoid triggering, and then do all the fun stuff to do that. That's pretty cool. You want some bad speedrunners? Bad in terms of they aren't number one? I don't think that's bad necessarily. Like I watch some speedrunners that aren't number one, but I wouldn't necessarily call them bad. Okay, let's see. So now we're going to take this collider and we're going to insert it into colliders. So self.colliders insert. Okay, so this is our collider, our parent handle, which is, oh. Okay, mute collider. Oh, so you need to be mute. Okay, that's gonna be, parent handle is a rigid body handle. Okay, so that's just the body handle. And then a mutable reference to self.bodies. And okay. You ever prefetch data? So far, all of my games have been 100% prefetched, but I've also not done a game where I can't prefetch 100% of the assets and have the game still work. So for example, in the Asteroids game, all of the graphics, sorry, there's no graphics. We just do all the draw meshes. All of the audio files are grabbed and loaded at load time. I'm not grabbing them ahead of time. So memory wise, perhaps not the best, but I'm not making anything big enough yet that I'm gonna need that. I am not a game developer unless you count these sort of side streams making games, but I have not published a game with expectation for somebody to download and like play that game at all. Maybe one day. I would love to like get to the point where I can create these little interactions and like make them available for other streamers to try out. I think that'd be pretty cool. I don't think I'm there yet. You learned about prefetching on the web. Oh, web prefetching is also pretty cool. Yeah, you can do all sorts of fun stuff with that. When I was teaching though, like several students, like I always recommend students to create at least one game for one of their projects. I think that the lessons you learn from game dev is like super important for like skill building. Let's see. Okay, so we insert the collider, and I think at that point, this is in here now. Now, if I come down here, we're able to grab the handle, so the rigid body handle and the body out of here. So we're able to get the coordinates of you. We're able to get your, okay, so we're just associating your radius. Now, this is a rigid body. Do I have... So I have like there, user data. I mean, I can get that user data, which potentially would allow me to store the sizes, like the radius. This doesn't seem to be right. Oh, but I could get the colliders off of it. Wait, colliders. The handles of colliders attached to this rigid body. Is there a reason to have multiple colliders on a single body? Would the reason be for like different types of like collision? Like maybe one that like only collides with triggers and one that only collides with bullets, that kind of thing. Sure, complex shapes, different properties, etc. Oh, okay. So like instead of trying to create like a single collider that's like a really complex shape, I could just do simple colliders, but multiple of them all around. So like I can do like 4 rectangles instead of like trying to like draw some like really crazy thing. Oh, that's cool. Oh, okay, we can get the position here. Oh, there's an apply force. Right, imagine a spaceship with a couple of colliders for the landing feet and one for the body, that sort of thing, which would allow me to then sleep the landing feet separately. Okay, I get that. So what we can do is like, once I learn a lot more, we can create a 2D Kerbal Space program. I don't think I don't think I'm there yet. Okay, I think so I can't get the radius from here. But if I go to colliders, that gives me, I guess it would be the collider this is probably a really bad idea then. To like get the actual shape of this. So I should probably use this user data to then determine what the shape is, and for like the radius. And then that way I can like set this up separately. So let's just do the proper thing here. Because maybe what I want to do is like these are all balls right now. So I would want to maybe we like have radiuses. Sure, why not? And you're gonna be a hash map. U128. And I guess you're just an F32 for the radius. So you're going to be a hash map. Hash map new, and then you should be able to figure out what you are from that. So then here and create ball. So what I'm going to want to do is our body we're not caring about necessarily, but our collider we are. Now, is that true? We are true about this because we're looking at the bodies for their positions. So we're gonna do a what was it called? User data. Okay. We pass in this data. So I can pass in something like your ID 1. But if I want to pass in ID 1, I should really then have probably like some wrapper around this user data. So let's just call this user data. Or maybe like this is going to be the entity data, I suppose. Okay, so we're gonna have entity data in here. So we're gonna have an ID, which is U128. No, I want this. It's not gonna be the ID of 128. This is gonna be like the next ID or something like that. Because that way I can then start using that. Then the actual data. So then we can do something like radiuses. Could be, here's where we could do a hash map. So a hash map of U128 and an F32. I guess that's all I would care here. When I create a new, just going to turn a self. So next ID is going to be 1. And radius is going to be a hash map new. So this is going to allow us to, in here, instead of like this radius is here, we're going to replace this with data, and you're an entity data. Entity data, new. Okay. Then in create ball, we need to like sort of get what this new one is. So we're gonna want something like an insert. So like insert entity. And we're gonna return the ID. So that's gonna be U128. So the way this is gonna work is insert data for an entity and return the ID, hit that data back again. Okay, so insert into here right now, all we care about is the radius. So that's gonna be F32. So the way this will work, we'll take in the current ID. So let ID is equal to self dot next ID. Before we forget, self dot next ID plus equals to 1. We're gonna return the ID. Then I want to insert into this hash map here. So what is that going to look like? That's going to be self dot radiuses dot insert the ID, and then the value is the radius. This gives me an option, but I don't really care about that option. It gives me whatever was inside if I care about that. So then in here, before we do this, we're going to say let ID, it's going to be the data d equals self dot self dot data insert, and then a radius, which is make you 10, and then user data can become data ID. There we go. So now we can get that back out again down here. So we have our handle and we have the body. So here we have this radius. What we really want to say is like let data ID is equal to the body dot user data. Oh, okay. It's just a property. So that gives us this huge 128 here. And let's now write a function to get the radius out of the data given the ID. Function. I know I don't really need that comment. It's pretty self-explanatory for what this is going to be. It's going to be get radius. Just need a reference to self. And then the ID, which is a U128. And we're going to return back. Now, I guess here's where it gets interesting because this needs to be an option, right? Or get the radius, the ID. If there isn't an radius for that ID, then return the default radius. So then I can always return an F32 here. And I could even put this up here. I can just say alt radius. Let's just say that you're 5. I should probably give it the type. And down here, radius, you're 5. All right, so here we can do a if let sum radius equals self dot radiuses get the key is a reference to the ID. Then return a dereferenced radius. Otherwise, return a self.default radius. Okay, so then we can, for this radius is self.data.getRadius and pass it in the data ID. And then we have our circle, which gives us the radius and puts it wherever it's supposed to be. Okay, so if I run this, cool. Trying to build a mesh with less than 3 vertices. Right, because we have absolutely nothing in here right now. Which is oh yes, we have absolutely nothing in here. So how do I want to deal with this? I only want to build if like there was something to build. I think we need to just not do this if we didn't build anything at all. I guess for right now, I'm just gonna create a flag, and then eventually, I don't think we're gonna need it because I'm gonna put like a platform at the bottom for everything to sort of like collect into, and that will be something that like is in this world right away. So there'll always be something to draw eventually, but right now we're not gonna have that. So let's just do should draw equals false. If we get here, should draw equals true. So if should draw is true, then draw. All right, you should be happier now. You're not. Right. I mean, there. Well, I mean, it's great that we have this blank screen, but for us to actually have anything interesting here, we need to now start inserting these balls in here. So what I want to do is maybe if I do like one per tick is probably not right. Let's do if timer ticks, if you modulus, let's say every 100 tick. So every 100 ticks, go ahead and do a self dot create ball, pass in the context, do that. So there we go. Now we get these balls that are sort of like they're just falling forever, but they're in random locations. Okay, so that's good. This is a good sign so far. Let's go ahead and commit. So we have this is basically just a work in progress commit. I'll do an amend commit later for the for like the day, the work we did in a day. I just want to be able to come back to this in case I screw it up later. Okay, what's next? I want something that they can fall onto. I was thinking maybe a bunch of, like, just a single rectangle. Come on. I screwed this in way too tight. There we go. Let there be balls, and lo, there were balls every 100 frames. Which is a little bit more than 1 second, right? Like 1.9 seconds or something like that. Okay, so if I want to create another like platform, I'm gonna have to create a body and a collider, but it's not gonna be a ball anymore. So let's say I wanted to do this in a in just a function here. So function create like the platform. I'm only doing it here. Let's actually just make mute self to make this a little bit easier on ourselves. I don't think I need, oh no, I'm gonna need a context, yeah. So my idea here for this is in update, I'm just gonna check to see, this is a terrible idea. Oh, I know how to do this. We can have a create platform here in main. After we create our main state, we could then just do things here. So we could do like, this is probably a better pattern for us to do, is like we have like just new for creating a new thing. And then I can just do a hub function like setup. We'll take in a context, which is that mute context. I don't know if we need to return anything, but then this will just call self.create platform, pass in that context. So now I can in main here do main state dot setup, pass it in a mutable reference to the context, and we're happy. So that way, I think it cleans it up and makes it a little bit easier to like sort of deal with and reason about. Okay, so in here, create platform. I want a rectangle just at the very bottom of the screen. That's all I want here. So we're gonna have our body equals a rigid body builder. And what do we have? This is going to be a static. It just sits there. New static. Okay, once we have that, so it's not going to, gravity is not going to be applied to it. Oh, we have to have a position for it. Now, I don't know if it considers the position to be centered or top left. That would be really nice. Let's try assuming that it's full center. So if it's full center, our X is going to be, well, then here's where okay, we need our width divided by 2. And then for the height, I want this to be something like height minus like 5.0, something like that. It doesn't really matter. Let's just do minus 10. Okay, so then we're gonna give ourselves a position and oh wait, no, not there. Position with no rotation. Now, user data, we might need to put something in here for that. The colliders would usually be the thing you position that determine if the body position is centered or not in a sense. Okay, so this one, I just need to be consistent. Okay, perfect. So then we're just gonna build you. We're gonna insert that in. So body handle, bodies, insert body. So that gives us that. Now we want to create the collider. Okay, so collider builder. So I want this to be a rectangle. Do you have one for that? I don't see that you have a, like any kind of rectangle, but we can do a polyline. Does that make sense? Yeah, probably polyline. Then we can just do vertices is a vector of points. Points is just, okay, a Rapier2d math point. So that might be the easiest thing for us to do. Now there's this other one, convex polyline. Creates a new collider builder that is a convex polygon formed by the given polyline assumed to be convex. What's convex mean? Having an outline or surface curved. Okay, so I do not need that. Just a polyline is probably good enough. So polyline takes vertices, which is a vector of points, and then indices is an option. But I don't know if I need indices at all. So let's do polyline. Okay, then we need the vertex of these. Okay, so we're gonna do a polyline vertices. So that vertices is gonna be equal to a vec of points. So math point, okay, so points. Okay, so new. Is it 0.2? That's two, right? Like there's two items in here. A pentagon is convex, a star isn't. Pentagon. Really? A pentagon is convex? Shape. But a star isn't? With straight sides. Look up convex polygon. A convex polygon is defined as a polygon with all its interior angles less than 180. This means that all the vertices of the polygon will point outwards, away from the interior of the shape. Think of it as a bulging polygon. Note that a triangle is always convex. Oh, interesting. With all of its interior angles less than 180. So if I'm doing a rectangle, that means all of its angles are 90 degrees. So down, down, 90 degrees. That would mean I'm making a convex polygon, right? Rapier does do that. I just didn't understand that I need that. Because I can do a convex polyline. Oh, convex hole. Also good. Hello, Danny. Convex hole. Yeah, they do that. And then points. Initializes a new collider builder with a 2D convex polygon or 3D convex polyhedron obtained after computing the convex hole of the given points. Although a capsule may be an easier shape to define. Oh, there's also capsule. Capsule X and capsule Y. Hold on. Initialize a new collider builder with a capsule shape aligned with the x-axis. What is a capsule shape? Ah, okay. So it is, that's sort of like what I thought it would be, but like I wanted to make sure. It looks like a pill. Okay, yeah. So essentially I'm going to make a capsule shape, but with like, oh, I wonder, am I doing a capsule shape, but like this part will be off screen? Half height radius. Okay. And then so okay, let's try the capsule shape. Capsule X, half height would be whatever we were setting our whatever width whatever height we really want to set to. So we're doing it like 10 here. Let's just do half height of 5. And then radius would be how long it's going to be. So that's going to be width divided by 2. So that gives us this collider builder. And is there anything else that we care about in here? A cuboid appears to be their term for rect, by the way. Oh, really? Cuboid. Initialize a new collider builder with a cuboid shape defined by its half extents. Oh, height x, height, wait, h. Oh, half x. Okay, I think cuboid is what I want then. Cuboid. So half of the x, this would be the width divided by 2, then the height divided by 2. So something else that I'm realizing now is this entire thing where I have the entity data with like the radius, that's great for like the balls, but this isn't going to help me at all when trying to draw out the platform for this. So we're gonna have to rethink how this works. We don't need these vertices anymore. Let's say I just build you now. Now, if I just do this, let's see, position. Oh, no. Takes one argument. Oh. Okay. Oh, right. This is an isometry to new position 0. That's what I want. Oh, you're shaping bread and pizza dough for dinner? Oh, that sounds so good. Okay, so where's my error? My error, okay. There's no error, but we're gonna have a problem. When I try to draw this, what do you think is gonna happen? My thoughts are, because there's no ID, it's gonna, I think it's gonna crash because I'm trying to get an ID when it doesn't exist. Either that or it's gonna draw a circle on the bottom. Look, there's our circle, and it drew it right here. That's not where I want it to be. And none of these are impacting with anything. So that's also a problem. So I need to somehow make it so that it knows that the position is down here. Okay. What do I want to do with this then? Oh, wait. I create the collider. Kind of need to put the collider in the actual thing. So we're gonna do self.colliders, insert. Okay, so give it the collider, give it the body handle, then immutable reference to self.bodies, right? Yeah. Okay, let's try this. That is interesting. It's not exactly what I expected. I mean, that's pretty cool. We're getting cool physics off of this. But I kind of expected it to come down to here. So now our position for the platform is with, yeah, that's really good interaction. You're definitely right about that. Okay, so height minus 10 is there. So it's like supposed to be all the way at the bottom, minus like 10 or so. The collider, this collider is really tall. Apparently. Oh, yeah, that's really tall. the height of this, we want you to be like 5. There we go. Okay, so that looks appropriate now. And we're able to get some good interactions with these. That's pretty cool. Now if I wanted to actually draw this out as like a solid line happening here. Hey Chantilly, good morning. What do I want to do with this? I want to... I need to somehow know that this is a rectangle and not a circle. So let's think about this. Down here in draw, these are assuming that it's circles here. And so therefore we're getting like, hey, what type of data are you? So I kind of feel that I need like a type too. So if we come here to entity data, we can get the radius out, but we only want the radius out if it's like an actual hazard radius. Otherwise, we're going to want a rectangle for the rect part of it for drawing. Other things is that we know. Yeah, okay. So I think what we need is the type also. So like the specific like type that is being set up here. So like maybe data type. Which is also going to be a hash map. Which, okay, it's going to be U128, and we'll have like a data type enum here. Let's create that up here. So here we can have like, we have a ball type, and then we're going to have a, like maybe like a platform type. And maybe I just want to be like more specific. We have a ball, we have a rectangle. I don't know. So inside of here, have a data types, hash map, new. When we insert, we also want, well, okay, so then insert is going to be more interesting, isn't it? We want to insert insert ball, which is going to insert, okay, let's actually change this. You're going to be a platform. Insert ball. So insert ball data for an entity. I don't think I actually need you anymore. Okay, so then we get the radius out here and we return the new ID. This isn't actually like best practices here, but as like I go through and it's like I build it more, I sort of like understand what I'm trying to do, and then I can rewrite the entire thing for like a real project with like a much better sort of data structure. Because like builder pattern might be better here, except it wouldn't truly be a builder pattern, would it? Would it? It would be like insert, but then we can do like insert, and then we're gonna like do a dot on that to choose one of the other ones. What if we rewrite it in C++? Yeah, that's a great idea. But I'm thinking maybe that could be a future thing. I'll add it to the list somewhere. Insert platform. And so then in this case, we want a width and a height. I know you're trolling. I know you're trolling. Playing off the why not rewrite it in Rust meme. Oh yeah, like, I don't know. I feel people go like way too far with those things. We can port it. Yeah, let's port it to the original Game Boy. Like, we need to know how many of these balls we can get on the original Game Boy. I don't even have one anymore. Mine broke and like I lost it decades ago. So let's see. Insert platform. We can do the X and a Y. I guess we would need an X, F32, a Y, F32, and a width, F32, and a height, F32. Oh, and we're gonna return this U128. So already we can tell we're copying and pasting some data here. It's not the best. So then we're gonna return the ID here. The biggest thing that we're doing here is we have to create this rectangle. Oh, radiuses. So we do self.radiuses. We're also going to do a self.data types. Insert. The key is going to be the ID, and then the value is going to be data type ball here. And then here we're going to do the same thing. Self.data types, insert D, data type platform. And then we can have maybe like, so the actual data then is going to be the rects, like the rectangles. Rectangles. It's going to be a hash map. 128. And GG easy rectangles. So in here in insert platform, we're going to create that new rectangle and insert it in. So that a rect equals a rect new x, y with height self dot angles, insert the ID and the rect. Okay. So now we can grab that out properly. So then the idea here is in our main library. So should draw equals true. So this, we shouldn't need this anymore. I'll remove it later. We get the X and the Y from the world position. We get the data ID. And then, so this is now where we're getting this radius. So now we need to like do a, I'm guessing we should match off of self.data dot, okay, we need to get. get data type. Give you 128, and we're going to return a data type. And let's actually, like, data type, we can actually put in here like not found. Like, we can just put a none in here, and this is essentially like an option. So now we can do if let sum. This is going to be the data type. Self dot data types get has a reference to the ID. That gives us a reference to this data type. We could have it be a reference to a data type, but that doesn't really make much sense. These are enums. They're like such a small space. Let's just go ahead and derive clone and copy. So then we can just do a dereference of the data type. Otherwise, return a data type none. Okay, so then in here, gonna match get data type, pass it in the data ID. That gives us this data type, can fill our match arms. Okay, so if we're a ball, then this is what we want to do. We want to grab all of you. So grab the radius. I don't know why you don't care about that, but okay. We basically radius, location, and then add the circle to the mesh. Okay, so that's good. Now, if you're a platform, I guess like if you're none, we're going to just do a no operation. So I think we can just do that. If we're a platform, then we want to get the rectangle. So that rect equals, we don't have access to that yet. So let's do getter in here. So this is where potentially we can create like the like a macro that just sort of creates these out for us. Function get rect, self ID. I'm gonna return a rect. I think we're gonna have to clone this one directly. You're a little too excited about your code working right now. Oh, that's fine. I think it's great to be excited about code working. Sum rect equal to self dot rectangles get reference to the ID. So I don't think rect implements copy. So else, we should do like a default rectangle too. Or we should not have like the default radius in here. Makes me think that it was broken for a very long time. I've run into those myself. Like we had an outage reported at our work a couple weeks ago, and when we went in to fix it, and I was doing the root cause analysis, I discovered that the outage had been out for 27 days. 27 days. Nobody could go to a page on our web app. That was bad. It was really bad. And yeah, I hate finding out that things were broken for a long time and I had no idea. Okay, so what do I want to do in this point? I want to then probably just like give it a generic rectangle. We can just do a rect new Let's do something like 0.0, 0.0, like, I don't know, 15.0, 15.0. Let's give it a nice little square. So if I do that, then back to here, we can do let rect equals self dot data dot get rect, pass it in the data ID. Then we're going to do a mesh builder dot rectangle, draw mode, fill. The bounds is this rect, and then the color, we can just make this white for right now. But I'll want to like change these around a little bit. Something end-to-end testing would solve that. Yeah. We didn't have end-to-end testing for that route. But on top of that, we didn't have end-to-end testing in production either, which would have helped out. So I'm now currently like, wait, like what's the, I'm heading a task force at work to basically set up status pages that will auto check certain routes and like just let us know as soon as they go down, so we can find out before the clients do. End-to-end testing is slow and expensive. It can be, but it's super important. It's like one of those things where it's worth the cost. I've actually never seen a successful argument for not doing end-to-end testing where, yeah, not can, it is. Yeah. I mean, yes, it is, but it's still really essential. You're a strong believer in minimal end-to-end testing. I'm in the opposite camp. But I go minimal unit testing and maximal end-to-end testing. Mainly because if the end-to-end tests are working, then I don't feel I need unit tests. No, less unit tests. Someone has the upside down testing pyramid. It's there are different philosophies. I can go into like a lot about like what my reasoning is for that. Now that being said, during building time, I like to have lots of unit testing, but once it's all out there and like I have the end-to-end test set up for our CI/CD pipeline, then I can delete the unit tests and we don't need those anymore. Okay, so we now create you. That should work, but I don't know if it's gonna be the right position. Oh, and you know what we need to do? We need to enter in a rectangle. I know. Okay, so what are you upset about? Oh, right, you're now insert ball. Okay, I never delete other developers' tests. No developer should ever delete each other's tests. This is more of, hey, I've written all the tests for my project. Now I have the unit tests. They do the same thing. I no longer need the other things. I would never, ever recommend that somebody deletes somebody else's tests. That's a terrible idea. And I would rather have too many tests than not enough. Like if I'm gonna err on one side or the other, err on too many tests. You're right, they don't do the same thing, but in the end, if the end-to-end tests are working, that's testing all of the functions too. Whereas if I only had unit tests, I still can't trust that everything is working. No matter what, I need end-to-end tests. So I can have end-to-end tests and unit tests, or just end-to-end tests. Okay, so we insert ball here, and then platform. You'll give me the last one, and that's the reason why I go to like that end is like, well, if they're kind of overlapping, it's sort of like dry at that point in time. But dry on like an entire huge architectural level. It's a, and I'm still willing to, as far as refactoring unit tests are infinitely better, I'll give you that too. Yes, refactoring, like if I need to refactor something a lot, then having a unit test is very helpful. So the key there is to never, ever, ever need to refactor. Just write it right first. Like if you write it right the first time, why do you need a refactor? I mean, yes, I'm trolling you now. Okay. What was I doing? Oh, we need to create the rectangle now and insert that. So, oh, right, to get the ID. So we have this body here. We're gonna have the body data inside. This is because you made this. No, I'm not punishing you. No, I'm not. Let's see. We're gonna do a self.data.insert platform. The X, the Y, the width, and the height. Okay, so now our position is in the center. So that means we need to go into the negative for the X and the Y. We need to do our negative width divided by 2. And then this is the width. This is going to be negative 10.0. Our width is just the width, and then the height is 10.0. We need let ID is equal to that, and then in here we're going to have a dot user data and pass in the ID. So if we do this, well, things aren't drawing out. So I don't have the circle anymore. That's a good sign. But it's not appearing where I sort of expect it to. So here in draw, okay, let's take a look at this. We have draw, we're getting this platform, so we're not drawing a ball. So it's either a none or a platform. I kind of want, let's debug here. Platform. We should be like, that should be hitting every single frame. It is, okay. So this is happening. Now I'm curious what this rect is. It should be the same rect that we put in there, but maybe it's like the wrong position. So negative 400, negative, oh, that's a wrong position. It's above the screen. That's our problem. The X is correct. The Y was horrifically wrong. I want this to be height. So X and the Y, you need to actually be height minus 10. There. I think that's what we need to do. There's our platform. Okay, so I've got this in actually the wrong position. So I believe I can just set you. to be zeros at this point in time. So platform can be 0.0. The height needs to be that, and then we have the width and height. Okay. There we go. So here's our platform that things are falling onto. Okay. So this is pretty cool. I don't need this debug statement anymore. So let's get rid of that. Now, what if I wanted to create the walls for this? Like we have the platform on the bottom. What if I wanted to create walls that these balls are sort of going to be stuck inside? And so they're going to be just sort of sitting here forever. Right now they're going off screen and then falling forever. So I don't want that. I want to like force them to stay in here and like stack up. Okay, so how would I end up doing that? In our setup, we have the create bottom platform. I'm gonna want to create a wall too. So function create wall. Okay, so we're gonna want our width. So I could just make this create walls. Width, height. It's gonna be pretty similar to this. We have our position is gonna be on the left-hand side to begin with. So that we can actually do this like create. Let's do create left wall. So we don't need that. We don't need the width. Okay, so I'm going to create a position of where the body is going to be. Position 2, vector 2, new. So I want this to be at 0. Oh, we want it to be in the middle, like the middle position. So I want this, let's say we have like something very similar. We have like a 5. We can make it just be a 5 width total. So this would be like 2.5. 2.5. And the height, we do need the height. Oh no, we have the height. That's going to be height divided by 2. So then here we can just do this as an isometry 2 new 0 go. So that's our actual position. We could create our ID, which is now going to be a rectangle for this. So self.data.insert platform. So in this case, I want this to start in the top left, 0.0, 0.0. Our width is going to be 5, and our height is going to be the height. So it gives us the ID. Then we can create our body. This is going to be another new static. With a position of the position. User data with the ID. We're going to build you. Okay, so we have self.bodies. Insert the body. Okay, that gives us the body handle. Then we create the collider. We're going to create this as a cuboid with the half X and the half Y. So the half X is this 2.5 for the half X, and the half Y is the height divided by 2. And we do self dot colliders, insert. Okay, the collider. The parent handle, so that's going to be the body handle, and then a mutable reference to self dot bodies. And that's it. Now, if I do this, so create left wall, so in setup, I want to then self dot create left wall here. I'm actually curious whether or not this is going to work. Like, are we done? No, we have an error. Mismatch types. Oh, build. Build. Did we forget anything? No, we didn't. That's all we need to do. So do we have a left wall now? Is that just something we get? We do! We have a left wall. Oh, that's perfect. Now, we do need to make sure when we're creating these balls, I need to make sure they're within, like, not touching the left-hand side. So we have this radius here. Let's go ahead and make sure that our position is gen range not become 0, 0, but essentially let's do I guess like 10.0 to width minus 10.0. Like that should give us, that should make it a little bit so it can never touch the wall. That was, there was one that started too close to the right-hand edge, I think. So I might have problems. Because if this starts at 10, let's just say you start at 10.0. Oh, no gen range. I just want you to start at 10.0. Yeah, do you notice like it's starting over here and then it's sort of rolling off the top? I don't want that. So you need to be like 20.0? Is that too much? Yeah, let's just 20.0. Okay, I think that's gonna be better. So then we can do self.rng gen range. Then the range is going to be 20.0 through our width minus 20.0. So then this should guarantee that it's always going to be inside of our container here. Okay, so then let's go ahead and create a right wall. A right wall is really the same thing as the left wall. So right wall, we do care about width now. So we get our position. This X is now going to be width minus 2.5. Height, that's going to be the same thing. We create a new ID. So X, you're now going to be width minus 0. Y is that? Width is 5. Height, okay. We have a body. Create that. Body, okay, insert the body. The collider is relative to the body, so that this should be fine. And then the collider, okay, then we insert the colliders. So if I do that, and then we call in setup, create right wall. Now, do we have a right wall? We do. And so I think everything is going to work out the way we expect it to. So one final thing I want to do, because we just have a bunch of like white and black stuff, which is not super fun. Let's create a color. So colors. It's also going to be a hash map of U128 and a color. Just for the balls, I want to like grab out the colors. So self colors, hash map, new. It's that. When we insert the ball, let's actually see. We can create a color in here probably. Color is a color. Then we're going to do a self.colors, insert ID and the color. All right, so that means over here in create ball, we need our color. We have access to self, so we do let color equals. Let's do color to from RGB. It'll be just, I think, a little bit easier for us to like deal with here. Then for each one of these multi-line views, we're going to do a self.rng.genRange. Let's go. So this is 0 through 255, with 0 being black. So I want like maybe lighter, brighter colors. We can start with like 150 through 255. And that's it. Then down here, we'll pass in the color. And then down in draw, when it's a ball, we need the color out of here. So we can do a, oh, we need to get color. All right, so now we have a get color function we can use. So color equals self.data, what? No, self.data, get color, pass it in the data ID, and we'll replace you with the color. Otherwise, the platform will remain white. And now we have random ball colors. So we can just leave this running here and see how this ends up looking. I'm gonna take this time to take a really short break and go grab a little bit more water for me to drink. So I'm gonna leave this running here and we'll see how it ends up looking. All right, I'll be right back. I am back. Ooh, it's looking good. Okay. Now I haven't told any of them that they can sleep. So that's why we're seeing them sort of like vibrating as they're being added in here. So this is pretty cool looking. I want to try this again, but we're gonna stress test it. And I also want to see how many we're getting when this is happening. So let's do inner update. First of all, I think we can remove this should draw now. Like this, we don't need you anymore because like we always have those platforms. So we have something. Spish Kairos, hello, how are you doing? Let's see, what's next? Oh, I want to inner update. Let's see, if we already have this ticks as 100 and we're creating a ball. Your cluster project is going well. Oh, nice. Oh, and so your day off. Well, thank you for joining me on your day off. Your cluster project, well, off meaning no streaming. Right, because you stream every day too, right? Like my day off is Saturdays. Let's see. Oh, you do other work, you just don't stream. Yeah. And I know what that's like. Like on Saturdays I don't stream, but I do like chores and I try not to ever touch like work. But there's homework. I get that. I get that. Okay, so every 100 ticks, we're creating a ball. I'm thinking I want to like make this a little bit faster. So let's do this so we're doing 60 ticks per second. So if I want to do like every half of a second, we create one, that would be every 30 ticks. We're gonna create a ball. And then I also want to find out how many balls we have. The easiest way would be to print out like the ID essentially, because that's like the count also. Want to hear about your cluster project? Sure. That's different than your than that other AI with like the light gun, right? Want to see videos the last time you made a collision system? I mean, oh, it's related to your AIs. Perhaps later. Like I'm not to that point yet where I'm doing like the AIs with like the collision detection and like the clusters and everything else. I'll try to remember to come to your cluster is related to your AIs. How about this? I'll try to come to one of your next streams. And then I'll ask there. So the cluster is like an HPC system. Ooh. All right, so every half second we're gonna create a ball, and then I want to print out how many balls we have. The easiest way we can do that is just make next ID public. Actually, you know what we can do? Is there a way to like get the number of entities in a body? So that would be self dot bodies dot, is there like a length? There is. Okay. So I can just do a debug of that. That's how many we have. So all right. So if we run this in normal Cargo run mode, the collision system is from your PhD work. Oh, that's cool. So here we have basically just a bunch of balls with physics using the Rapier2d library. Every half second, we're creating a new ball in a random location at the top of the screen. They're falling down and interacting with each other. I've got platforms on the bottom and the left walls, sort of like to keep them contained. And then that's it. We're just sort of like seeing how many we can get in here before we end up having performance problems. Although me having just like the number of bodies in here is probably not enough. I also need to know what the FPS is. So we can do, this is the, we can do like the count is that. But I also want to do a debug of FPS. Actually, I don't think I need the label. I think it already has the label for me. This is going to be a timer FPS. All right, so let's run this, and we should see every half a second or so us showing what our FPS is. This, oh, we've got VSync on. We've got VSync on, so it's around 60 frames per second, regardless of what we do. If you want to see cool stuff, see the damping to near zero, pump it to like, set the damping to near zero, pump it to like 80% full, and slowly increase the damping. These are pure circles. What's damping do? Also, the other thing I want to do, I want to turn off VSync. Is that window mode? I think it's Windows setup. VSync, false. Remember the controls, how bouncy. Yeah. I've got, let's see, in balls. Restitution is one, and I think that's the bounciness. 2D glasses are quasi crystals. Oh, interesting. Okay, well that's gonna be different because I can set these to like if I set this to like 0.3, I just turned off the VSync, so if we rerun this, we should see a lot less bounciness, just less fun, right? Like that's not as cool looking. But I can jump this up to like a 1.5. At some point in time, it'll bounce faster than it. Okay, these are still stopping, so that's good. But now we get tons. So this is basically a 2D molecular crystal of glass. That's cool. Oh, did you see that? We got some balls that are just bouncing forever. Now our walls only go up to the top here. They don't go up forever. So any ones that escape out the top, that's it. They're escaping out the top. They're gone forever. Now we can see the FPS is slowly going down. We're at like 600, a little bit above 600 right now, with 100 entities at the same time. Perhaps this is a little bit too much bounciness. Let's just do like 1.1. That should be good. Fun time suggestion: add a block that goes about 20% of the way up and go from 1/3 to 2/3 of the axes, and watch what happens when the balls spill above it. Oh, because then it should spill down, right? Yeah. Now I don't know if this is gonna like change. Let's also make these happen a little bit faster. I want to an update. Let's have every frame we create a ball, but then every 200 frames we'll print out how many balls we have and what the FPS is. Got your physicist hat on? You did research on this? You wonder if... Oh, Steve is available? I don't know. Okay, so we're getting massive problems here now. This is fun. I'm gonna have to... It never got to the next 200 frames to tell me how many we got. So that's not great. Yeah, we should probably cap the number of balls. I have no idea how many we got before frame rate. Let's see. If self dot self dot bodies dot length is less than, let's try 100 to begin with, then create a ball, and then we'll go ahead. So this will create a bunch of balls all at the same time. We'll create 100 of them. So we're getting 652, 540, 521. Yeah, we're gonna try that next. Is run and release mode. Yeah, I know the packing is pretty nice. See how they're vibrating there? Because I'm not letting them go to sleep. So they're staying active, which is pretty cool. Okay, so we're hovering around 500 frames. Now, if I do release mode, and we recompile, we should, I'm curious to be how much better the frame rate is going to be. In Rust, our running things in release mode can make things insanely better. So we'll see. Now, if I could get 1,500 items on the screen at the same time, I would totally do that. Can you try adding the defect generator you suggest? Let's see. What's the defect generator? Is that... Was that the... It's not the block that goes halfway up. That's the... Damping near zero, pump it to 80% full, and then slowly increase the damping. Is that which one? Or no, the block. The defect generator is the block that's 20% the way up and go from 1/3 to 2/3 of the x-axis. So basically just like a block like this, right? Okay, look at this. 100 of them, and we're getting 1,716 of these. That is really nice. Like that, but on the bottom. Okay, so basically down here. How far up did you say it should go? One. Oh, wait, does it is it going from here, like all the way from the bottom, or is it just in the middle of the air where stuff can go below it? We want the ball spilling over it from the bottom. Okay, got it. Basically a pillar. We're creating a pillar. Yeah, we can do that. Let's see. How would we do that? Let's do a create pillar. Because that sounds pretty fun. So function create pillar. All right, so what do we need here? We need to know our width and height. So let's width, height, graphics, size. Okay, so now we have the width and height through the entire screen. We want the position of what this is. We've been doing the positions as the center of things. So our position is equal to an isometry 2 new. This can be a vector 2 new. Okay, so the x and a y. If I want it to be exactly in the middle x-wise, that should be fine. Wait, yeah, that should be fine. So we want it in the middle x. That's going to be width divided by 2. And then now the height. If we're going up by 1/4, like 25%, was that it? Let's see, 25%. So I can do our height minus, and then also take our height and multiply it by 0.25. And then we have no rotation. Okay, so that gives us a position. Then let's go ahead and we need to create the actual like rectangle that's going to draw out for that. So that let the d equals soft dot data dot insert. Sure, this will be a platform. The x, where we're going to put this. So if I want this to be like 1/4 of the distance, I need to get a whiteboard. So if I want to throw you something like this in here, so math, especially live math, not my strongest suit. So I may need your help to make sure I don't do this wrong here. So let's say I think we're on like 800 by 600 or so. So if we're on, like, let's say we have this as like, this is a width, whatever it is, like we're gonna figure this out. We're not gonna do like exact calculations. So this, like, if I want to make this a bigger thing, that'll be fine. So we have our entire width there. Obviously I don't really care about that. Then into here is our center. So I need to figure out where this is here. So, because I need to know what this width is in order to take our center and minus half of this. So if I want to make that 1/4 width, Rx, oh, right. And, yeah, so we need 1/4 width. So maybe it's 1/4 of the width. So that could be, width divided by 2 minus width times 0.25. We can try that, see how it feels. And then y is going to be the double this, because this is in the middle. So this is going to be height minus essentially twice this. That'd be half the height. Height divided by 2.0. And then the width is gonna be width divided by 2, and the height is height divided by 2. I think that's how it's gonna work. Okay, so then create the actual body. It's gonna be a new static. Okay, position, give it the position. User data, give it the ID. And we build you. Okay, then we do self dot bodies dot in. Oh, wait. Let our body handle. Utsby, thank you. Width divided by 2 minus haha, yeah. Hold on, where am I doing this? Width, so here, width divided by 2 minus that. So this can just be our width times 0.25. Okay, perfect. What did I do? Yeah, I don't know. This is gonna be the same thing then, right? Height just times 0.5. Yeah, height times 0.5. Or yeah, height 0.5. Oh, your coffee smells good. That I've never really gotten into coffee. Self dot bodies. I'm more of a tea drinker myself. Bodies. Insert the body. That gives us a body handled back. Then we're gonna create our collider. Collider equals collider builder. We're gonna create a cuboid for this. Okay, half of the X. So half of our width for this is width times. So this is in half. So I want width times 0.25 instead of 0.5. And then the same thing here. So height times 0.25. Has it been 10 minutes yet? Probably. I'm always slower at these things than like I want to be. Okay. We create the collider. We build you. Then we insert the collider. So self dot colliders dot insert. All right. So we give it the collider. We give it the body handle. Oh, hello. Oh, Steve. You're Steve. Hello. Okay, so we have our body handle and then a mutable reference to self.bodies. I don't really care about the collider handle. So theoretically, it just works now. You know what would be really helpful? When you create a function, Well, the thing is, like, I only get 100 of these things in here, so we don't get too much. Should make a periodic boundary conditions and make a heap. I don't know what that means. Oh, so Steve and you worked together in glass research back in the day. Oh, that's cool. Love how these are like just very slowly. I don't have any, I must have almost no friction, like very little friction on, because they continue to roll and they never stop. So that's pretty cool. Now, oh, I only get 100 because I just I have it in update to limit ourselves to 100. So what I really want to do, and 200 is maybe a little bit too slow for this. What I want to do for here, I want to continue. Let's try it. Let's try 1,000. And let's, I don't know if I want to add them all at once. I kind of, let's do every 10 ticks, I'll create a ball. So if that's that, okay, so every 10 ticks, if, let's just create a ball, and then I'll just have to manually stop it if we're getting too low on FPS. You drop the pillar height by like 1/4 and set it to, like, the width, you mean, to 150? Wait, is this Christmas music? What? No, stop. Okay, so we're still going on. Now our FPS is like at 425, 430 or so we're still good. Oh, meant the height is running well. Awesome. I don't exactly know what I'm looking for. So it's looking pretty cool though. I like this. Not at this time of year. Okay, cool. We're filling up this entire thing. And we're still getting really, really good FPS. Why is mobility propagating? I need to reduce my restitution so they can settle. That's probably a good point. I have restitution too high. Let's do that. Restitution. You know what I haven't looked at is what restitution actually means. Where's my ball creation? Create ball. Okay, restitution is at 1.1. Let's try like 0.8, something like that. You know what? We were getting resting with 1.0. Maybe that's all we need. So while this is happening, what is restitution? The restoration of something lost or stolen to its proper owner. Recompense for injury or loss. Yeah, definitely what's happening here. I'm returning stolen energy. coefficient of restitution. Okay. Okay. The coefficient of restitution, also denoted by E, is the ratio of the final to initial relative velocity between two objects after they collide. It normally ranges from 0 to 1, where 1 would be a perfectly elastic collision. Okay, so I might want it to set it to less than 1. Restitution is conservation, so it's conservation of energy, right? So I have perfect conservation of energy here. Look, they're collapsing in on themselves. They're, oh, interesting. I didn't, I haven't like set what kind of like, oh, they're compressing. But of course, I don't know how to draw them compressing. I'm drawing them as circles. They're not actually, like they're compressed. Ooh, and now they're being forced down through the bottom of the floor. Interesting. Is there a way to control how rigid the objects are? Probably. So in our rigid body builder, I can give them additional mass. You have it set to dissipate all energy. Well, and it's glitching that too, but I have it at 0.8 now, and I had it like 1.1 before. So that's not terribly surprising, I guess. How's my FPS? Good question. We're at 300, between 330 or so, and we have 1,080 or so of them. So we still have like a lot of these in here. And we have over 300 FPS. You want to drop the mass. Okay, so I can do additional mass. How do I set the mass to begin with? Fine. Mass. I can do additional mass properties, or mass. Or mass properties. Okay, so I can say where the mass is. Okay. Dropping the mass, so basically they're, well, dropping the mass so they're lighter and like sit on top of each other more. So they can become like essentially plastic hollow balls is what we're thinking about. So we can do mass properties. Okay, so let's try this. So, okay, we're down to we're almost at 2,000 and we're down to 150. Overlapping usually means you need more iterations for constraints solver. I don't know how. I'm too new to this library. But what we can do is in the body, we can reduce our mass. So we can say, I can do additional mass properties. So mass properties. new. Okay, so points. I think it's gonna be that. And then the amount of mass, I don't know, 0.1, 0.0 for initial inertia. Oh, you're not happy. You need 2 of them? 1 of them? What's your error message? This function takes 2 arguments. Okay. 0.0, 0.0. There we go. Expected 1 argument, found 2. Cool. Thank you, Rust Analyzer. Oh, okay. We got to 2,000 entities and we're down to like 50 frames per second. Now my goal is to eventually have 1,500 of these on the screen at the same time. So I'm kind of happy with where we are. But if I have like very low mass now, I'm interested in like how this is going to affect the simulation. Want to decrease mass? I think that I did. I set the mass. Am I supposed to like do minus some amount of mass? Because I don't know what it's set as. Because I don't set an initial mass. Because you. So rigid body builder. We have these mass properties. Oh, mass properties, 0. So we have 0 mass. We have 0 mass. So when we're now having more mass than we had before. I know. They removed a mass and like set it to additional mass, it seems. I know it feels a little bit odd. Now I don't know how to like increase the simulation quality or anything else like that. I don't think like making it try to have this negative mass is a good idea. Well, all I did really, where am I initializing the sim? I am initializing the sim in new, essentially, I think. It's like in new here, we're creating all these things. Pipeline, new. Then an update. We just do. Then we just step. So I don't know how to initialize it if there are initializations. What are the rigid flags? Basically in rigid bodybuilder, which this is the document, this is the link to the documentation I'm looking at. So the rigid bodybuilder here, I have access to like all these functions that I'm using. I don't know if there's, set gravity lower. Yeah, I could set gravity lower. It'll move a lot slower, but yeah, we could do that. And set gravity much, much lower. So way up here, we have gravity. We can try like 25. Run that. Integration parameters should be would be where it is, I imagine. Something like position iterations. Okay. So we'll let this run for a little bit. Let's go find this documentation for integration. Okay, integration parameters. Parameters for a time step of the physics engine. Okay, so this should be fine. Do we want it to run faster than what I'm doing? Oh, don't forget to turn mass back to 0. Yeah, we can do that. Turning mass back to 0 would just be turning off this additional mass properties. And rerunning you. Okay. Max position iterations on the left. Okay. Where was that? That was max position iterations. Maximum number of iterations performed by the position-based constraints solver, default 1. I wish they had examples of like where to use this. So how many would I want to have? Like 2, 3, up it to 4 or 5, see if it helps. Yeah, okay, we could do that. Gravity down. Well, it's not smooshing yet. I don't think it was smooshing yet anyways. I think that happens a little bit later. But okay, this is integration parameters. Where do you take that? Integration parameters right here. So we have default dot max position iterations 4. Oh, wait. Okay, let's set you to 4. Oh, okay. So if I want to do like a new. Oh, then I have to add all this stuff myself. I don't want to do that. So, sorry, Clippy. I'm going to do a default and then just change this one thing. It's going to be fine. Don't worry. Okay. All right, yeah, they're definitely not collapsing it. Interesting design patterns that they're creating as they sort of like add in here. You need to up gravity again to reproduce the air. See if that helps. Yeah, we can do that. So we can up the gravity. So let's up that to like 200. And let's try it again. So I guess like something that I always felt is like upping the gravity usually seems to be like the go-to for making like falling objects in like games. Like your player falling down is like to make it more good feeling Is that usually the way to do it, or do you normally just set how much an object like the player object is affected by gravity, and then just keep gravity normal? The doc suggests integration parameter. Oh, default. Oh, I don't think I've ever done that before. That's cool. There. Okay, they're getting squishies. Those patterns are where the crystals are finding energy minimums. Oh, interesting. Okay, so that's actually like, that's an interesting sort of like recreation there. I like how like it squishes down at. So should I be creating them as like a higher mass? Upping the gravity, increase the energy in the system. If you do that, you need to adjust the parameter from before near one by default to change the same bouncing behavior. So, oh, reduce it. The conservation energy parameter, yeah. So I guess as for tweaking, you usually have to mess with things if you're really making fairly out there multiple context structures like this. Yeah, I figured there'd have to be a lot of tweaking. If I want things to fall fast but not to crush each other, then gravity is probably not the way to do it. Gravity is not the way to do it. So if we put U back to 25, lower mass. Mass is already at a 0. Can I set mass to negative? Let's see. What else? I mean, I know that would be like impossible in the real world. We can try it. What's the worst that could possibly happen? I doubt that this thing can allow me to simulate the creation of a full black hole, right? It's maybe not impossible. When scientists say that, I sort of feel that we're now working with quantum levels. And that's usually when I'm like, okay, I'm just gonna go look at the pretty pictures of the simulations. Okay, so we're not gonna mess with. You know what? There was one thing. There was something that we can do. Gravity scale. It says the scale applied to the gravity force affecting rigid body to be created. So if I set this to be like, if we're at 25 and we want to like 250, if I set this to 10, is this affecting the movement or actually affecting it? Affecting it like how much it hits everything else. I don't know. I'm curious. Okay, so now we're getting the same. Ooh, okay, in the. Utsby, thank you so much for stopping by and helping out with some of the math. Have a great rest of your Sunday. Let's see if they crush each other with a lower gravity, but each ball has a modifier applied to the gravity. What were the rigid body flags from before? I can go take a look at them. I can see some squishing, so this is definitely not working. They're still being affected by gravity just as much, which is destroying each other. So that's cool. We can also play with density, I think. too. So this, I don't think we care about that. We want the rigid body builder. So I'm creating a dynamic rigid body. What was that? I just got an alert warning. Oh, I just got a severe thunderstorm warning. It's raining right now, apparently. Well, that's fun. It's smooshing. I see the smooshing. I guess, like, how do I make it fall fast, but not crush each other? Like, I'm also okay with not having that be a thing. I was just sort of thinking, like, if I use this to make a game, but I don't know if I want to use this to make a full game. Because it feels to me like it's actually going to be harder to customize everything that I want for, like, how the movement works. Yeah, they were by the gravity, but then they crush each other. So, like, if I want the best of both worlds, the age. Some of these are almost through the floor. You want a severe thunderstorm where you are? Where I lived, the thunder is not directly overhead usually. They become more dense at the bottom, which is cool, but not what I want. Oh, that's what it... Oh, interesting. Okay. I guess what I was hoping, like, this is probably just me not understanding, like, what I'm really getting myself into. It's realistic, which is really cool, and there's probably some, like, cool artsy things that I can do with this to create some art with code. I was thinking, like, how can I use this for, like, game type stuff? And that's really hard. I don't know how I would do that. But yeah, this is pretty cool. It's like they're crushing each other. We can make you know what? Spishkairos? We can make Tetris, but with realistic physics, so it crushes the bottom layers, right? I don't think that would be very playable. I think the problem I have is less of you should make them hexagons and not spheres. That could be cool. My problem here is drawing them. So I'm drawing them manually as just circles with, like, the position and the radius. I would need to know what the new information is for this. Because even if I'm in hexagons, I probably still wouldn't be able to see the deformations unless I got the new hexagon information. RHCP as the answer. So at this point in time, I'm creating new ones. I'm assuming quite a few of them are rolling off the sides. These walls only go up to the top of the screen, but they're being They're being created right here, 10 pixels above the top of the screen. So I assume they're now starting to be created right on top of each other and then just explode outwards and then going away. Random hexagonal close packing. What I would somehow need is if I did hexagonals, I need like the new dimensions of what it is. And rigid bodies don't have like the actual sizes of the bodies in it. That's the collider. So if we look at the collider, I can get the position of the collider. It's how you pack the objects in the space that matters. So a sphere gives you RHCP. You can see the hexagons in your image. Yeah, I can see them actually creating little hexagons. That's pretty cool. But if you did them as hexagons, you can see the rotations and the packing better. Oh, okay. Yes, even if I didn't actually make the hexagons squish down in like actual the image according to what it's supposed to be. I can reset the shape of them. Interesting, okay. So if I want to do extremely realistic, it would be a lot harder. But like the property of RHCP that matters here is interparticle spacing, and basically a line that defines the closest point between each set of particles gives you a hexagon. Oh, okay. A lot of this is sort of like going over my head. It's sort of like, ooh, we're creating cool little artsy stuff. Oh, wait. We just crashed. We crashed because assertion failed. Dimensions, minimum bound. Did one of them squish too small? Oh, greater than equal. Something inside of the physics engine broke in the geometry. Anyways, we got 2,998 balls. We were getting 13.937 frames per second. So what I want to do, this like having our let's see, what do I want to do? I want to go ahead and reset. Let's see, there's that there for a ball. Let's not gravity scale up by an insane amount. And I'm gonna stop having our platform to set up. We're set up. Let's not do the pillar. And in main, let's also create a whole. Let's change our window size. Can I do? It's not here. It's you. Dimensions. Let's continue with the 800. But let's do something like 1200 for the height. So if I run this, we should have like a long cylinder for all these balls to drop into. Okay, so this is fine here. Now I want to find exactly how many I can add in before we drop into not great. So I want to do is in our update loop. So how do I want to do this? The FPS here gives me the average across the last 200 frames. So like the best thing to do would be like wait 200 frames and then add in a ball. That's, however, I do know that we can create something like, oh, I think we can do over 1,000 frames, 1,000 of these balls. Let's do this on every 100 frames. It's like half. So 100, 0. I'm going to create a ball and I'm going to check the length and the FPS. So if I do that, I run you. I'm not allowing any of these balls to sleep, so this is going to be essentially a worst case scenario. Spring model anywhere? No, I don't. So if I'm doing anything, like they're doing it somewhere. So now, okay, thank you so much. I guess like Steve or Kendom Lane. What do you prefer to be called? But thank you so much for the subscription. Let's see. Call you anything, just not late for dinner. Well, in that case, well, welcome anything. No. Welcome, Steve. Awesome to have you here. Thank you so much for the subscription. So what I'm going to do is I'm going to leave this running for a long time. And then I'm going to check in later, see how many of these I was able to get onto the screen at the same time, with our FPS above 60. And you know what? I did this wrong. I don't know how to delete items out of here. I'm sure that's something we can do. Do is if ticks is greater than 100. Oh, you know what? I probably want to do this outside of this while loop. Let's do this down here. Okay, so if ticks to 200 is 0. So every 200 ticks, every 200 ticks, then I want to do a if let's get the FPS. So FPS equal to timer FPS. Then if FPS is greater than 60, then create a ball. Then no matter what, and then that, like, create the ball, tell us how many we have, give us our FPS. That's what I want. Steve, thank you so much for stopping by. I am probably going to shut the stream down pretty soon. I usually stream only until about noon. And my throat is like, I've been talking a lot, so my throat's starting to feel it. So I think I need to go grab lunch and relax a little bit. I do stream in the mornings on weekdays too. So if I don't catch you, well, obviously you probably won't be back in time today, but hopefully I'll catch you another time. Okay, so if I do this, let's go ahead and start this over again. We're gonna create a whole bunch of these balls, and as soon as we go down to like close to like I don't know, 60 frames per second, it should stop for us, and then we'll see how many we're gonna get. We're probably still gonna get the deformations because I imagine we're gonna get enough of these. Actually, no, we're not, because I told them not to be affected by gravity by that much. They should just sit nicely on top of each other. But what I'm going to do is I'm going to, what's my plan for this? Oh, great. Thank you for asking. I almost forgot. My plan, I am going to be creating so this is going to be a fun random chooser. So I want to, for any number of items, I'm going to have like a file with like one item per line. And then we're just going to create a bunch of the circles at the top, have like some kind of like barrier preventing it from falling, have them initialize, turn on physics, remove the barrier, have a bunch of nails in here, and they're all just going to like bounce around. And then one of them is going to be the first through the hole in the bottom. That is going to be our winner. And so that's going to be a way for us to randomly choose things in the stream. It could be things from like what we're going to be working on next to like maybe if we do like a giveaway or something. It could be that too. Or any number of other things, like maybe what game I'm going to play next. I wanted to be able to handle 1,500 things because unfortunately my backlog for playing games, or at least checking them out, is 1,500 large. So that's why I wanted to make sure that I can have enough of these. You can set it up so that chat can enter. Yeah, actually that's what I'm going to do, is I'm going to have it be run one program which collects chat and then adds their names into a physical list, shut that down, and then start this up, and it reads from that list to create the circles. So that way they all go off at the same time. But yeah, we're going to do a chat integration. Essentially, kind of. It'll be a 1-2 punch. One for the chat and then one for like the actual drawing of the lottery. And I kind of already have the chat integration. I could create another one that would just take the names and just throw them into a file. But yeah, that's exactly what I want to do. Look at these nice little formations here. It looks pretty cool. And as we can see here, we're already at 700, almost 800, and we're at 500 frames per second still. So I know it's a huge backlog. A lot of them I don't think are actually playable, or I want to play, but I don't know. So anyways, all right. So I'm going to leave this running, but I am going to shut the stream down. However, there's a whole bunch of these here. So we're going to first start by shutting the YouTube part of this video down. So thank you so much for watching this if you're on YouTube. And I will see you in the next video.